So the compound angle formulae are brilliant things for allowing us to split either known angles into angles that we can calculate maybe without a calculator or something like that, or for finding out information about things that are kind of tucked up together. So for instance, we might have cos of 75 degrees, and I might go looking in my bag and I might not find my calculator, but it's okay because I could split that up into cos of 30 plus 45. And using the compound angle formulae, I could get expressions in just cos 30 and cos 45. Cos 30, I know what that is, and cos 45, I know what that is too. And suddenly I don't need my calculator. Alternatively, we might be dealing with something like this. And just occasionally, people have attempted to expand this out in answers. So this is not correct. I'm going to change colour because it is not correct. But I've seen this before quite a few times. I'm sure I've slapped some people's wrists about that. That is not right. We're going to learn how you actually expand that out today. That's what the compound angle formulae are. So these expressions where you've got two things sort of added or subtracted together with a cos or a sine or a tan outside, that's a compound angle. And we're going to learn how to expand these. So here I have a unit circle. I know it's a unit circle because I'm choosing it to be, and so I'm going to label my radii, so two of them, 1 in both cases. And I have drawn an angle, I guess from the horizontal, but it's an angle that measures A plus B. I can do that, that's fine. And now I'm going to look at this length here and this length here. So I've created myself a little right angle triangle, and I'm interested in knowing what these two sides are. So the opposite here, this is our opposite, and this is our adjacent. Well, from GCSE, can you see the pattern? From GCSE, we know that sine of the angle, whatever the angle is opposite over hypotenuse. Well, my angle here, that's A plus B. So my angle, sine A plus B, is opposite, not sure what it is, over the hypotenuse, which is 1. So I could describe the opposite as sine A plus B, and I'm going to do that now. So I'm going to take out opposite here, and I'm going to describe it as sine A plus B. Likewise for the adjacent, well, I know cos of the angle, whatever it is adjacent over hypotenuse. Substitute in what I know my angle, that's A plus B, and I know my hypotenuse is 1. So I could re-describe the adjacent as cos A plus B. So let's do that. Right, at the moment this hasn't gotten us anywhere. We still don't know how to expand these things. We still don't really, well, we know what they are. They are compound angles. They are angles stacked on top of each other. But we're no closer to finding out how to expand these things or how to use them. That's okay at the moment. I just want you to keep this idea in your head. What we're going to aim to do, is to find, wrong colour. Let's try that again, shall we? We're going to find equal lengths, there we go, and describe them out of not other things, but just sine A's and sine B's, hopefully, that are equivalent to these. And hopefully we will find either an expression for this whole length, or an expression for the cos A plus B bit, or maybe a little bit here, so we could form some sort of equation. But again, just in terms of cos A, sine A, cos B, sine B. And then because they'll be equivalent, we'll be able to equate them, and then we'll know how these things expand. So that's what we're going for. So just keep those lengths in mind and keep our target in mind. We're going to go and find equivalent lengths. Okay, so the first step to finding these equivalent lengths, because I'm going for knowing something, wrong colour again. I'm going for knowing something about this length, but in terms of just sine x and sine A and cos A and sine B and cos B, and also something about this length in terms of those things as well. Those are what I'm going for. Now, the obvious thing to do here is, because I've actually created this angle A plus B, I don't want that as a full kind of angle that I can't break apart. So let's pick a random place, shall we? And we will turn that into A and B. So we're going to take this cos A plus B out. I'm going to split our angle up. So that full length, that's still a 1 because we're still on the circle, still radius. There's a B and there's my A. Now I've created a series of new, or I can create a series of new triangles here. So I can create that one. I could create, well, I already know this one, that's the original one I wanted. I need an angle in terms of B, so it'd probably be helpful if I try and create a perpendicular to that slope there, because I can know things about that. Now, it would be ideal if I could work out this whole length. I'm just colouring in blue now, so I need to kind of go past my circle here. And also if I knew probably this length here, and also this length here. So we're going to go for those bits. Now, they might not be there exactly. We might end up having, I don't know, this blue line possibly more like this, because that might be more useful to us, and therefore our little red line being more like that. I think that's what we're going to go for. Okay, so let's draw this out a little bit clearer so we can actually see what's going on here. I had my angle A plus B. I've then chosen to split that angle up again into some slice B and another slice A. So I've still got my angle A plus B here, but I've split them back up again. And then what I've done is I've created some more right angle triangles, because I can always find out information about them. Now this B one was a little bit more difficult, but we created it at a perpendicular to this middle radius, because that gives me my right angle, and that's a lot nicer than some of the other angles I could create. Now, what do I know about these angles so far? Well, I know this line in here, I'm just going to pop it in very gently and then I'm going to take it back out again. This one in here, this is my sine A plus B, and I also know this one along here, this is my cos A plus B, cos bracket A plus B, sine bracket A plus B. But there are some other things I could find out. So for instance, I'm going to do all my, remind me, actually you can't because you're listening to this and I'm the only one here. I'm going to try and do all of my vertical measurements in blue and all my horizontal measurements in this whatever colour, pinky, salmony colour. I'm sure you'll be screaming at your computers if I change that. So, let's see. Okay, what can I know? This opposite here, that's sine A. If you're not sure about why that's happened, go back and have a look at how we've generated these opposites. And likewise, this whole length here is cos A. That may or may not be useful to us. And, okay, so it's not a vertical, but we'll pop it in as a vertical for now. Actually, no, I'm going to pop it in white. This slanty line here, this is the opposite to the angle B. So that is going to be sine B there. And this, can't even see that. There you go. There we go. That adjacent, so it doesn't go all the way, it stops at the edge of that right angle there. That's going to be cos of B. Okay, I'm going to put in a sneaky line. I think that the line I want to find, the one that's equivalent to the one I'm just colouring in now, that blue line there, is going to be this one here. And then I'm going to take out my cos A here, because I don't think that's going to be very useful to me. But the bit I'm colouring in salmon now is the thing I want to find. That's my cos A plus B. And I think that I'm going to make it by looking at this whole length here and this little length on the top here. That's what I'm going for. So I need to find ways of describing those sides. Now I've just created a little right angle triangle at the top here. I hope you can see that. So let's just pull that out and you can have a proper look at it. A minute ago I said that this hypotenuse here, that was sine B, because that was the opposite of the original triangle we had. And I know what this angle is at the bottom here. I hope you can see it as well. That's angle A. It's A because if I just have a look at this triangle here, there's my angle A, so this is going to be 90 minus A, and then we've got this 90 minus A and 90, leaving me with A on the 180 degrees there. So that's the angle A. Now we're getting somewhere, because I can start to describe these other two sides. So standing at the angle A, this salmon line, that is my opposite. And that we can describe, well, we know that sine A is opposite over the hypotenuse. We know that the hypotenuse is actually sine B. So my opposite is sine A sine B. So this length here, that's sine A sine B. And this adjacent in the blue, well, I'm going to need cos for that. So cos A is adjacent over hypotenuse. And I still know my hypotenuse. That's sine B, sorry. So the adjacent over sine B is cos A, in which case the adjacent is cos A sine B. Okay, so this little bit here, this is cos A sine B. And this bit here, this is sine A sine B. We're getting somewhere. We're getting somewhere. Okay, so I've created so far this little bit here, and I want to know what this bit is here. And likewise, I'm interested in this length. Now this is almost the triangle we created with A, except I've shortened my hypotenuse from 1 down to cos B. So let's draw that back out again, out of the circle, and we'll have another look at it. So we've got our angle A in the corner here, and this hypotenuse, this is cos B, and that's come from the way we labelled our B triangle, the triangle with B in the bottom left corner. So by the same arguments then, and if you're not sure about them, do pause the video and go through them using the same arguments. This angle here, this blue line that I've just drawn in here, this should be sine A cos B. And the salmon line, that should be cos A cos B. Let's piece this all together then. So we had a triangle that was part of our circle with our angle A plus B, and we said that this opposite here was sine A plus B, and this adjacent, this was cos A plus B, and these were the things that we were trying to find out more information about. We then found that the little bit at the top, because this was part of a little triangle, I hope you remember it looked a bit like that, although mine has changed orientation slightly, we found that to be cos A sine B, and we found the bit across the top to be sine A sine B. We found this long salmon line to be cos A cos B, and we found this last bit of the vertical height to be sine A sine B. So sine A plus B is equivalent equal in length, equivalent, and we haven't chosen our angle, so it can be any size, in fact, so it will work, to sine A sine B plus cos A cos B. So we're stacking these two together so we can add them. And this line is equivalent to that line. We know that cos A cos B is equal to, so this long line here is equal to cos A plus B, thing we found originally, plus sine A. I've written something wrong here, haven't I? What have I written wrong? There we go, copying error. I hope you didn't do this in your exam, everyone. So this bit should be, what are we up to? Sine A cos B, that's better. There we go. Where were we? Oh yes, so this salmon line across the top here, that's sine A sine B. In which case we can rewrite this. Cos A plus B is equal to cos A cos B minus sine A sine B. So notice in the compound angle formula for sine, the plus stays as a plus, and in the cos compound angle formula, the cos changes to a minus. But we've done it. We've done what we wanted to do, which was just to create expressions in terms of cos A, cos B, sine A and sine B, because those are things we can manipulate. We already know how to use those. So just to recap then, sine A plus or minus B, well that's sine A cos B, and the plus, if it's a plus in the compound angle, stays a plus in the expansion, and if it's a negative, minus, it'll be minus as well. So we can leave the plus and minus the right way round there, and we would end up with cos A sine B on the end there. Cos A plus B is cos A cos B minus, so they actually swap over. Tan is tan A plus or minus tan B over 1. Right, now these swap over, so if it's a positive in the compound, it will be a negative in the expansion on the bottom here. Tan A, tan B. I'm going to leave you this to prove, and I will check you've done it in class. I'll give you a chance to do it in lesson. Just consider the fact that tan A plus B could be written sine A plus B over cos A plus B. Expand them both out, and then you need to do some serious cancelling, but hopefully you'll get there. Just persevere, it gets a bit messy. The compound angle formulae, which are in the formula book, are brilliant because they lead to several other key results that will really help you manipulate trig. And it's going to be so important that you have these to hand, that you recognise them, that you recognise the forms they can come in the question, that you've learnt the ones you need to learn, that you are familiar with the other ones. Even though these ones are in the formula book, the compound angle formula, I'd really recommend that you learn them. Just because then you're really familiar with them, they're actually accessible to you, not having to think, hang on a minute, I know something like this, but you can't think what it is. You will actually need to learn these double angle and the half angle, but we'll come to those in the next video. And the factor formula is in the formula book, but again, recognising it is absolutely key.